All right, let's dive in. Today, we're going to pull back the curtain on something that powers pretty much everything you do online: system design. It's the hidden architecture, the invisible magic behind every app you love. And to really get it, let's kick things off with a massive question.
No, really, think about that. Millions of people all hitting play at the exact same moment. How does it not just explode? The answer isn't just throwing more computers at the problem. It's about having an incredibly smart plan. And that plan? Well, that's system design.
So to figure out how they pull that off, we got to start with the basics. You see, just like an architect would never, ever try to build a skyscraper without a detailed drawing, developers can't build huge apps without a blueprint of their own.
At its heart, that's exactly what system design is. It's the master plan. It lays out how every single piece, the code, the servers, the databases, is going to work together as a team. It's kind of like planning a massive party. You've got to figure out where the drinks go, who's controlling the music, and how to make sure everything runs smoothly, especially when the whole neighborhood shows up.
Let's make this super real for a second. Think about an app like WhatsApp. For it to work, you've got all these different parts doing their own thing. You have servers that are just passing messages back and forth, databases that remember all your conversations, special storage for all those photos and videos, and then you have APIs, which are like the waiters of the system, running back and forth between your phone and the servers.
But here's the crucial part. There is no one single perfect blueprint. System design is actually an art. It's the art of making tough choices, what we call trade-offs. You can't have it all, so you have to decide what's most important for what you're trying to build.
Okay, so a classic trade-off is what kind of database to use. Do you go with SQL, which is super organized, like a perfectly neat spreadsheet? That's great for things like user profiles, where every single entry has the same format. Or do you need a NoSQL database? Think of that one as a big, flexible folder full of different notes. It's perfect for handling just insane amounts of different kinds of data, like all the photos, comments, and videos on your Instagram feed.
Another huge decision is the architecture itself. Are you going to build a monolith where your entire app is one giant program? It's way simpler to get started, which is awesome if you're a new startup. Or do you use microservices, where the app is broken up into dozens of tiny independent programs? It's more complex to manage for sure, but it lets a company like Netflix update its payment system without ever touching the video streaming part.
And, these choices change over time. Twitter is a perfect example. It didn't start with the crazy complex system it has today. Nope. It began as a simple monolith. But as it got huge, it had to break itself apart into microservices just to handle the traffic. And today, it uses even more advanced patterns to make sure your timeline updates the instant someone you follow hits post.
All right, so once you've made those big early choices, what actually makes a system great? Well, you can think of it like there are these essential pillars that hold the whole thing up.
First up, we have scalability. This is all about one question. Can your system handle a sudden flood of new users without grinding to a halt? You can scale vertically, which means making one server way more powerful. Or you can scale horizontally, which just means adding more servers. It's like instead of trying to make one chef cook faster, you just hire a bunch more chefs for your busy restaurant.
Instagram is an absolute master of horizontal scaling. They couldn't possibly store billions and billions of photos on one giant server. It's just not possible. So they use this technique called sharding, which is a fancy way of saying they chop up their data and spread it across thousands of servers. That lets them scale almost forever.
The next pillar is reliability. Look, things are gonna break. It's inevitable. A reliable system is actually designed for failure. It expects things to go wrong and has backup plans ready to go, so that you, the user, don't notice a thing.
Think about it. When you're in an Uber, your trip information isn't just sitting in one place. It's being copied to multiple data centers in different cities. So if a data center in, say, Virginia has a power outage, another one in Ohio just takes over instantly. Your trip continues without a single hiccup.
Of course, none of this matters if the app is painfully slow. Performance is all about speed. We live in a world where attention spans are, let's be honest, pretty short. A delay of just a few milliseconds can be the difference between a happy user and someone deleting your app for good.
Ever wonder why WhatsApp feels so snappy and instant? One of the biggest reasons is something called caching. It stores your recent chats right there on your phone. So when you open the app, it doesn't have to go ask a server for them every single time. They're already there, boom, ready to go.
And finally, the pillar that really holds up all our trust, security. This is all about protecting the system and your data from bad actors. It means proving who you are, controlling what you're allowed to see and do, and scrambling your data so that even if someone steals it, it's just gibberish.
And, once again, WhatsApp is a gold standard example here. They use what's called end-to-end encryption. That means your message gets locked the second you send it, and it can only be unlocked by the person you sent it to. Not even WhatsApp can read what you're saying.
Now, the cool thing is, engineers don't have to invent solutions to all these problems from scratch every single time. Over the years, they've built up a toolkit of proven solutions for common issues. You can think of them like well-tested recipes that you just know are going to work.
So, take the traffic jam problem. If way too many people try to visit a website at once, the server gets overwhelmed and crashes. The recipe for that is a load balancer. It basically acts like a traffic cop, directing all the incoming requests to a whole group of servers so no single one gets buried. This is exactly how Google handles billions of searches every day.
Or what about the real-time update problem? You add something to your Amazon cart on your laptop, how does it magically show up on your phone's app a second later? The pattern here is an event-driven architecture. That add item click is an event, and it triggers a chain reaction that instantly updates the system everywhere.
Okay, so we've covered the what and the how, but let's get to the why. Why is understanding all this stuff so incredibly important? Well, it's about making the jump from just writing code to building technology that truly makes an impact.
Honestly, understanding system design is what separates a junior engineer from a senior architect. It's the difference between being a feature builder, someone who codes one specific button, and being a system thinker, someone who designs the whole blueprint to make sure the entire application can work for millions of people without falling over.
And the impact on the business is just enormous. A well-designed recommendation engine in Amazon doesn't just show you stuff you might want to buy. It drives engagement, it massively increases sales, and it directly fuels the growth of a trillion-dollar company. That is the incredible power of good design.
So that's it. That's the invisible world hiding behind your screen, a world of blueprints and trade-offs and some really brilliant engineering. Hopefully, the next time you tap an app on your phone, you won't just see a little icon. You'll see the choices, the pillars, and the architecture holding the whole thing together. The only question is, what blueprint will you see?